जैसा कि आप सभी लोग जानते हैं कि हमारे इस वीडियो में आज मैं आपको बताने वाला हूँ चैप्टर नंबर 1 मैटर इन आवर सराउंडिंग। ओके, चैप्टर नंबर 1 मैटर इन आवर सराउंडिंग इज अ चैप्टर ऑफ क्लास 9, चैप्टर नंबर 1। ओके, और इसके चलते मैं आपको ये बताऊंगा कि देखिए, सबसे पहले स्टार्टिंग के अंदर हमको इस चैप्टर में यह चीज बताई जाती है। ये एकदम इंग्लिश का चैप्टर होने वाला है। इट वुड बी गोइंग टू बी द इंग्लिश चैप्टर। ओके, इंग्लिश लैंग्वेज चैप्टर। ओके, डोंट एक्सपेक्ट हिंदी फ्रॉम दिस लेसन और दिस फ्रॉम दिस वीडियो। ओके, और in the starting of the chapter, the NCERT describes about the Panch Tattva: air, earth, fire, sky, and water. These are the five matters. Okay, what they are discussing about? They are discussing about the five things. Okay, what are the five things? Okay, could you please repeat it? What are the five things? Okay, what are the five things? What are those five things? Five tattvas. Okay, Panch Tattva. Panch Tattva. Okay, Panch Tattva includes air, earth, fire, sky, and what's next? Water, man. Water. Okay. These are the five things that are being included in the Panch Tattva. Okay, in the starting of the NCERT chapter number 1, okay, of the class 9, they discuss about the Panch Tattva, and then they start playing about the physical nature of matter. Okay, physical nature of matter. How does the physical nature of matter describes upon? Okay, the physical nature of the matter will be described upon the state how it is presented over us. Okay, and it also says about that particles. All the particles have the minute or the micro distance between each of the, or the spacing between each of the particles. Okay, and those differences or those distances will create the kinetic energy on upon the heating it, and that will also create a kinetic energy, and that kinetic energy will forces the particles to move around it. Okay, move in a propellant motion. Okay, that would be very important for us to be discussed in this lesson. Okay, and then on we have the state of matter. Okay, state of matter. How the state of matter is being described here. Okay, how the state of matter is being described over here. That would be very easier for us to be described in this chapter. The state of matter. State of matter means how the state of matter could be present in this chapter. किस प्रकार से जो मैटर है, मैटर मान लीजिए क्या होता है, मटेरियल। मटेरियल कौन सी चीज के अंदर, तरल पदार्थ के अंदर माध्यम में, या फिर सॉलिड, लिक्विड एंड गैस। व्हाट इज द स्टेट ऑफ मैटर? ओके, स्टेट ऑफ मैटर। State of matter. State of matter are of three types: solid, liquid, and gas. Okay, solid, liquid, and gas. These are the three state of matter, and state of matter where we are discussing about it. Okay, and then we are on the matter is made up of small particles. Okay, matter is always made up of the small particles, which consist of minute tiny particles, which could be micro particles also. Okay, and matter around us exists in the three states: solid, liquid, and gas. Okay, that I have already said to you. And then we are having the forces of attraction between the particles are maximum are maximum in the solid and intermediate in liquid and minimum in gases. Okay, the forces of attraction, मान लीजिए forces of attraction क्या होता है, जैसे मान लीजिए मेरे पास ये एक ईयरबड्स है. ओके, मेरे पास क्या है, ये ईयरबड्स है. क्या इन ईयरबड्स के अंदर एक सॉलिड पीस है. ओके, it's in solid bits. It can't it can't break because it has some attraction in this material. Okay, which binds this together. Okay, something we can say like gum or fevicol, anything. Okay, fevicol, anything that is present in this earphone that binds this material so that this earphone doesn't break, because as it is very tiny. Okay, it is tinier than my finger. Okay, this is tinier than my finger size. Okay, and this is very tinier and it can't break it. What's the reason behind this? There is a force of attraction, and that makes it more difficult to be what we can to break it down. Okay, and this type of attraction is always present in a solid material, be it anything. Okay, be it any solid that can't break it, okay, easily, that it is called in a solid or liquid. What's a liquid? Liquid has a what we can say then a smoothness on its surface. Okay, has always a smoothness on its surface. Okay, and when we pour a liquid or the water in the glass through the bottle, you will see that it doesn't left any what we can say sharp what we can say sharp what we can say that word I don't remember it. The sharp ends on the both the sides. Okay, there is not any kind of sharp end on the both the sides. Okay, both the end sides of the breakdown. Okay, and when we talk about the gases have the most least attraction between its matter. Okay, between its matter, be it in we can say in the atmosphere has almost every type of gases present in it, and there's a variety of mixtures. Okay, and that's where we come across this, the space in between the constant material, particles, and the kinetic energy of the particles are the minimum. In the case of solid, intermediate, and liquid, maximum. Okay, the space between the constituent particles. Okay, तो space between the constituent particles. Okay, मान लीजिए एक space है ना, ये एक particle पर बना देते हैं ना. आपको स्क्रीन के अंदर मैं आपको बता दे रहा हूँ, स्क्रीन के ऊपर मैं बता देता हूँ आपको, ये स्क्रीन के ऊपर मैं आपको कुछ बना के बता देता हूँ. ना स्क्रीन के ऊपर मैं आपको बता दूंगा अभी कभी. जस्ट ए मिनट. ओके, be it solid. Okay, let's call it for solid. Okay, solid, if we take solid, have a very type of bonding in it. Okay, this is space between the solid. Okay, there's a very minor space between the solid. Okay, and we call for liquid. Liquid, we go for liquid. Okay, a liquid have this kind of space between this. Okay, this is very spacious. Okay, and when we go for gases have this. Okay, very greater space between this. You can say the space. Okay, there's a very lower space between this, and for the liquid there is a very lower, and for the solid has the least spaces between it, as they have to bind it very stronger to be come in the category of solid. Okay, and when we arrangement of the particle are the most in cases of the solid and ठीक है, or liquid layers of the particle can slip and slide over the each other and when the gases are okay. In the solid, these particles will never move. Instead, they are being disturbed. Okay, instead they are being disturbed. And for the liquid, this can go anywhere. Okay, this particle can in place of this can take place of this. Okay, for the gases, this particle can take place of this, and these kind of the things can happen easily in the solid. In the solid, these kind of the things will never happen because it is the comes in the category of the solid. Okay, as we have already discussed about it. And the solid have the least mobility of the particles. Okay, we are talking of the mobility of the particles. Okay, here we have the next point is state of matter are convertible state of matter can be changed by changing the temperature or the pressure. Okay, we can change the temperature or state of the matter. Okay, we take another example. Okay, we are having a new example over here. The example is let me take it out. Here we have the new example about example is what we take water. Okay, if we take water for the ice. Okay, water will be in liquid. Okay, liquid, solid, ice in the solid, and next is gaseous. Okay, gaseous state will be having the vapor. Okay, water vapor in the atmosphere. Okay, water vapor in the atmosphere. Here we are having water vapor in the atmosphere. We can transfer this solid into the gas or liquid by what the process? Okay, by process of heating it. Okay, it could come in a liquid, and liquid then goes to the gases by heating it. Okay, there's the process. Okay, these are the process of the formation of the liquid and gases and the solid. Okay, transformation of this type of change in the pressure and the temperature. Okay, by the change in the sublimation is the change of the liquid solid directly to the gases and without going to the solid. If we go directly to the gases. Okay, solid if we go directly to the gases, this called as sublimation without going through the before we had to go solid then liquid then goes to the gases, but if solid directly goes to the gases, then this process is called as sublimation. Okay, this process is called as sublimation. Okay, this process is called as sublimation. Deposition is the change of the gas state directly to the solid state without. Okay, so gaseous, if the gaseous process, okay, this gaseous goes directly to the solid, then it is called as deposition. Okay, what is called as deposition? Okay, this is called as deposition. Okay, this process is called as deposition. Here we call the gases directly goes to the solid. Boiling is the bulk phenomena, and particles from the bulk of the liquid change into the vapor. Okay, here we have to take the new example. Okay, let's clean up this board. Okay, clean up this board. Okay. And here we have to take the bulk phenomena of vaporization of liquid directly to the vapor. It's a liquid. Okay, it's a liquid water. We can always take the common examples. Okay, here we have the liquid as a liquid for we can take what we can take. We can take the water as an example to be called in the liquid formation. Okay, liquid state. The bulk phenomena of bulk phenomena. Boiling is a bulk phenomena of directly the liquid into the vapor. Okay, that's called formation of boiling water. Okay, if you keep the fire over here, what we keep fire over here. The conversion of bulk, okay, particles of water, bulk particles of liquid goes directly to the vapor particles, okay, in the form of vapor or gaseous form in the atmosphere. This formation is called as an boiling, okay. This formation is called as an boiling process, okay. This formation is called in the boiling process. Okay, this formation comes in the boiling process. Okay, vaporization is surface phenomena. Particles from the surface gains enough energy to overcome the force of attraction. Particles of the liquid changes into the vaporization. Okay, when we take the particle, okay, when we take the big pond, okay, we take the big pond, okay. Big pond or the big we can take the vessel where we can put the water in it, okay, where we can put the water in it in the larger surface area, okay. In the comparison we can take the glass, okay, we take the glass, okay, whose surface area is very lower than the exposure to the environment, okay. Here we have the sun can expose its rays. What could you think the who's having the higher expectation of fast vaporization of its liquid particles to the gaseous particles, okay. We can see here the large wasp who's having the larger exposure to the environment or the atmosphere have the higher chances of getting faster vaporization, okay. There we have the winner over here is this large wasp, okay, who will have the faster and what we can say is faster and easier conversion of liquid particles to the gaseous particles, okay. When we take the example of this glass will have the lower and very low speed of evaporation, okay, where very low speed of evaporation into the atmosphere of the liquid particles or to the gaseous particles, okay. The rate of evaporation depends upon the surface area exposed to the atmosphere, then the temperature and the humidity and the wind speed, okay. This I have already explained you, okay. Larger exposure to the atmosphere, and it also depends on the humidity, okay. Humidity, when already the atmosphere has more amount of the atmospheric vapors are present. The atmospheric vapors are present in its atmosphere. Water vapors are present in its atmosphere. Then the atmosphere will not have any kind of higher what we can say is higher intake of this liquid vapors into the atmosphere, because already the atmosphere is consuming or having humidity in the atmosphere, okay. What the humidity means? The humidity here, humidity means that the atmosphere is already having some kind of atmospheric water vapors in it, okay. And that water vapor will slow down the evaporation process of any kind of liquid or any kind of liquid vapors into the atmosphere. When we take the example of clothes to be kept for drying into the open sun, the sun then it takes quicker time, okay, low times to dry it up when the sun is fully immersed into the sky, and will have the higher expectation of fast drying of the clothes, but when the its temperature or the humidity will have the higher in this atmosphere. Okay, when the humidity is high, evaporation will be low. Okay, evaporation will be low, and when the humidity will be low, evaporation will be higher. Okay, that's then very fast explanation or the easy explanation I can explain you. देखिए, जब जहाँ भी ह्यूमिडिटी बहुत ज्यादा हाई होती है, वहां पर एवोपरेशन जो है, एवोपरेशन लो होगा, और जहां पर एवोपरेशन हाई होता है वहां पर ह्यूमिडिटी लो हो जाएगी. ओके, दैट्स एन वेरी साइमल्टेनियसली एग्जांपल. ओके, evaporation causes cooling. Okay, evaporation जो होता है वो cooling अपने को एहसास प्रोवाइड करता है. when we take of any kind of what we can take there are very examples. Okay, in the daily life. Okay, latent heat of vaporization is the heat energy required to change the 1 kg of liquid to the gaseous atmosphere present at its boiling point. Okay, latent heat. What's the latent heat? Okay, what is latent heat? Can you explain what is latent heat? Till I'm rubbing this board. Okay, latent heat. What's the latent heat? Latent heat. What's the latent heat? The theory describes about it. The latent heat of vaporization is the heat energy required to change 1 kg of liquid to the gases at its atmospheric pressure and its boiling point. Okay, what is latent heat? Latent heat is energy that is required to change 1 kg of liquid. 1 kg of liquid. Okay, 1 kg of liquid we can say of water. Okay, liquid we can say of water to changes into the gases. Okay, to changes into the gases in its at its boiling point. Okay, boiling point, and in the presence of its atmospheric pressure. Okay, AP, atmospheric pressure and boiling presence of boiling point and atmospheric pressure. What's the boiling point of the water? Okay, 100 degrees Celsius is the boiling point of the water. Okay, 100 degrees Celsius. Okay, 100 degrees Celsius is the boiling point of the water. Okay, and every liquid has its different boiling points. Okay, and latent heat of fusion is the amount of the heat required to change 1 kg of solid into liquid at its melting point. Okay, what about the latent heat of fusion? What's the latent heat of fusion? Let me read this. Who knows this latent heat of fusion? Please write it down while I'm reading it. Okay, what's the latent heat of fusion? Okay, latent heat of fusion. What's the latent heat of fusion? The amount of heat required to change 1 kg of solid. Okay, solid, be it ice. Okay, the easier example for the solid we can say in the state of matter is always be the ice. Okay, always be the ice. Okay, the ice to form into the liquid. Okay, liquid particles. Okay, 1 kg of solid requires how much heat to changes into the liquid. That's called liquid heat, latent heat of fusion. Okay, that's called latent heat of fusion. That's called latent heat of fusion. And the presence of its melting point. What's the melting point of an ice? Okay, melting point, it can be anything. Okay, 0 degrees Celsius can be melting point of an ice. Okay, as 0 degrees Celsius is what we can say freezing point. Okay, freezing point of an ice. Okay, what's the freezing point of an water? Okay, freezing point of the water is minus 1 degree Celsius. Okay, minus 1 degree Celsius. And what's the melting point of the ice? 0 degree Celsius. Because after the 0 degree Celsius starts, okay, let me explain you it in the deep manner. Okay, deeply. it's in chart. Okay, here we have the 0 degree Celsius, -1, -2, and here we have 1 degree. Okay, 1 degree Celsius, 2 degrees Celsius. Okay, and beyond this, this is for the water. Okay, water. Okay, only I am explaining this for the water. Okay, not the other kind of liquids you can take for the petrol and anything. Okay, I am not explaining about that. I am only explaining about the water. Okay, here with 0 degree Celsius is a neutral point. Okay, neutral point is it goes for the 1 degree Celsius, then it starts what we can say, it starts melting, and for the -degree Celsius it starts what we can say becoming the ice. Okay, freezing point for the water. Okay, freezing point for the water. And what's the melting, what I can say, what we can say, boiling point. Boiling point for the water is around 100 degrees Celsius. Okay, 100 degrees Celsius is the boiling point for the water. Okay, and we have other kind of these okay, what I am doing this, I am explaining you from the book. Okay, NCERT 9th class chapter 1. Okay, chapter 1. Okay, and chapter 1, matter in our surrounding, that I am explaining you from directly from the NCERT only. Okay, I am explaining no kind of other kind of data I am going through. Okay, and what we can say is let me remove this, and for the easier explaining of this kind of data, you can go through these summary points. Okay, these summary points will help you once you have to read the chapter. Okay, once you have to read the chapter, and then you can easily go through the summary points to get it quickly revision of this chapter very easily. And some of the measuring quantities and their units to remember. Okay, you can remember this, what we can say is temperature. Okay, temperature, for temperature you have Kelvin, and its symbol is K. Okay, its symbol is K. And for the length, okay, for the length you can go for meter. Meter is unit for this. Okay, it's R come here, not here, and its symbol is M. Then mass, kilogram. Then kilogram has a symbol of kg. Then you can go for weight. Weight has Newton. Newton stands for N. And then you can go for volume. Volume, cubic meter. Okay, cubic meter, m cube. And density. Okay, density you can go for kilogram per cubic meter. Okay, kilogram, kg per cubic meter. Okay, and kg, m3. Okay, and then we have pressure. Pressure has Pascal, PA. Okay, and these type of the units you have to learn for this chapter or this for the class 9 science. Okay, for the class 9 science, as this is the basic of the starting of a chapter, and this always describes you about this starting or the end till the end of how the level of this science book is going to be. Okay, how the level of this science book to be going to be. and that would be going to be very easier for you guys. Okay, just you have to go through first of the chapter reading, and then you can go for the summary. Okay, that will be very easy. And if you are having exams tomorrow, and have a good luck, as I know, please learn it on the time. And I know we have also done like you guys. Okay, and thank you for what, thank you for what, thank you for thank you for watching. Okay, and bye. Thank you for watching, and have a nice day, and all the best for your